Yeah, and today I'm going to talk to you about summoning spirits, and specifically the spirit of the Dankshard. And I'm really glad to actually continue after Leah, because I will also talk a lot about the rollups, because this ceremony is a way to open the next chapter of Ethereum scalability thanks to rollups. And so I believe it's a very important topic. Like, well, any speaker here hopes this topic is important, right? And because this is a part of big part of Ethereum roadmap. So if you are familiar with this lovely picture which Vitalik puts together on occasion, these are the urges of Ethereum, right? Yeah, we got the merge then. Whoa, mostly. There is still half of the stuff missing, or like there are many improvements to be made. And right underneath it is the surge. So the surge is this whole block within the roadmap. These are many things which are being researched, which are being developed in parallel. And specifically, as you can see here, the surge aims for achieving high transaction throughput. The surge is a way of handling the layer 2 data more effectively, so we can actually allow Ethereum to scale orders of magnitude. So why do we need this? Why do I talk about the scalability? Well, it's because the gas fees, right? So we have this trilemma of scalability, or the trilemma of blockchain security, because the way how blockchain work, or like the goal of the whole Ethereum here, is to create some decentralized, uncensorable, permissionless system, right? Which requires that everyone or many people are able to easily verify everything that is happening in the network with their client of Ethereum, with the implementation of Ethereum. Right now, if you are running a validator, or is there anybody who runs a node here? Oh, so many people. I love it. Yeah, I was expecting like 0. I love it. So you can see there are some people, and there are some user experience problems, of course, that it might be not easy for less technical people, but also there is the hardware cost. Right now, you need like a terabyte SSD or more to be able to actually verify what is happening in Ethereum network. Otherwise, you are relying on third parties. You are trusting in Fiora with your security, with all the privacy. If I'm mean, I say that you are not actually using Ethereum. And this is why we have the gas fees. We limit the data and the execution, the computation that the Ethereum can do in order to make the single client, the actual instance of the Ethereum easier to run on your computer, on your laptop. Currently, average laptop can do it, but if we just let everybody put whatever we want, like some alternative chains which sacrifice this feature do, it would be impossible, right? I would need like, I don't know, $10,000 server to be able to handle all the computation happening, because sometimes there is actually this kind of demand for the Ethereum block space, and this demand reflects to the high gas fees. Ethereum being permissionless open, we want everybody to be able to use it. It's not supposed to be just a toy for rich people, right? And that's why we need to scale. We need to find a way which doesn't bring many trade-offs, which enables us to scale Ethereum, to make it easier cheaper for more people, for more transactions to get on Ethereum, without sacrificing security. So if you're around for a bit, you might heard about the word sharding, or the Ethereum 2.0 at the time. And the sharding was, at the time, I would say like the ultimate answer to the scalability questions, one of the most important answers to these questions about Ethereum scalability. And it was like a phase within the original Ethereum 2.0 roadmap. And the sharding basically is an idea to, instead of handling everything on the Ethereum itself, we have just one network, the beacon chain, the coordination layer, which can verify data from many other, let's say 64 other networks. And there have been some changes over time. The original roadmap of having the Ethereum 2.0, where we suddenly changed to the beacon chain running shards, was prioritized for the merge. So the merge happened first, as we know, right? We actually now have the beacon chain as the consensus layer of Ethereum, which is implementing the proof of stake, and now this enables us to make it into the coordination layer for some shards or some other networks. And the idea of or the specification, the actual way how the sharding is supposed to work also changed. I would say it's a bit more elegant, and it uses random data sampling to ensure data availability. It's called the Danksharding, pioneered by Dankshard Feist, a great researcher from Ethereum Foundation. But meanwhile, before this sharding, we have L2s, or the rollups, right? The layer 2s enable some sort of scalability even today, because all this sharding stuff is in the future. And there has been just great talk about the rollups technology, so I'll just sum it up. What rollups do, building the layer 2 of Ethereum, it's some sort of a native way how to improve the scalability in a permissionless manner, in a way that this own network, the own chain of the layer 2s, or layer 2 network rolls up its data and puts them on Ethereum once in a while. So it's using the Ethereum block space more effectively in a way that it has to put it puts some rolled up data on Ethereum, and now this data, because we believe that Ethereum is secure, right? So now what is written on Ethereum is true, and we can use this to verify the integrity of the layer 2. In case of optimistic rollups, we can create a fraud proof. So based on the data on the Ethereum itself, which was put there by the rollup, I can make a proof that what is happening on the layer 2 is not correct, and I win something if my assertion is right. So that's fraud-proof system in optimistic rollups, and in ZK rollups this is done with the zero-knowledge proofs. So there is a verifier running on the Ethereum itself in the contract. And so the thing here is that the rollups are basically can inherit the security of Ethereum. We can, if this is done properly, we can say that the rollup is as secure as Ethereum. However, it's of course not that easy. And talking about the scalability itself, how does it actually work? So after the merge, Ethereum is a panda of the consensus and execution layer, and the consensus is the beacon chain itself. It's the coordination of all the validators, etc. And the execution is the former, or like the Ethereum client. It handles the actual execution of the transaction, the EVM, the state and the database of Ethereum. All the data are still here. So rollups send their transaction to the execution layer, and they keep it, they execute it in the EVM, and they create new state. They basically put their data in form of call data on Ethereum. In practical terms, this means that there is a bunch of useless data in Ethereum right now. These are just some examples from Optimism and the ZK rollups. There is Arbitrum missing, and the Arbitrum is the most used one, so it's even bigger than the Optimism. And if you ever send a transaction, let's say in high-fee environment, you know that like some maybe more complex Ethereum transaction can cost you, which is big, like few bytes, and does a bit of execution can cost you a few dollars, few tens of dollars, or even hundreds when the day is bad, right? And now imagine putting gigabytes of data there. Well, it's expensive, and that means that this call data, this rolling up the data on the Ethereum itself, that's the most expensive part for the rollups. That's what makes right now it's few cents, but still majority of this fee on the layer 2s is because of the cost of the data on Ethereum itself. Because, well, now you folks who are running the nodes, you are storing all of this data. And The way how the rollups work, that they also achieve sort of finality. When the fraud proofs on optimistic rollups, the challenge can happen within just like a week. That's why we have the week withdrawal period in the native bridges. But basically, I have just week to use this data to challenge the state transitions. And if I don't do it, the data is just sitting there and I don't really have a use for it. What is solving this ineffectivity is a proposal called Proto-Danksharding, it's a community name. The actual name is blob carrying transaction. This is pioneered by Proto-Lambda and researcher developer, and basically it changes the way how these layer 2 data handling works in a way that instead of putting all the data directly to Ethereum, to EVM, just in some contracts, what we are doing is that we create a new transaction type called blob carrying transaction, which carries a blob. Blob is just some bunch of data, which I don't care what it is. But I send the transaction with this data, and I create a KZG commitment to this data, which is a cryptographical commitment to a polynomial, which makes sure that basically it's a proof that the data, exactly this data, this blob of data exists here at this point of time. And now what I'm doing is that the rollups can, without some EVM execution, without a bunch of expensive data in the EVM, they put there just the commitment, which is a fraction, and the blob itself, the actual data, is not handled within the state, within the EVM, but it's put actually on a beacon chain, to be specific. It's just sitting there. This is not precise. The data are on the consensus layer. The commitment is in the Ethereum itself, so it can be, the data can be accessed through the commitment. However, this arrow is not really correct. I'm not talking to the consensus layer. I just send a transaction and it will be stored there via the NJ API. However, the beautiful thing here is that this data on the consensus layer will just disappear after a few weeks. We just throw it away because, well, we don't need it anymore. If it was supposed to be used for fraud proofs, it already was, and otherwise it's useless, so we can just throw it out. It costs us much less computation, much less space, and the layer 2s can just store the data in some alternative way if they want to keep it. However, this is the Proto-Danksharding, which will allow massively scale the current rollups. And why is it called Proto-Danksharding? Because it's basically like a first step to the full sharding, where the layer 2 data, the layer 2s are basically becoming the shards, and their data is already handled by the beacon chain. So I'm talking about this KZG commitment. It's some black magic cryptography over there, which has been chosen because of its features, because of its properties, which are really good trade-off. The KZG enables to create easy proof. However, the trade-off there is that it requires so-called trusted setup. This is where it gets scary, right? Trusted setup. So you might heard about this within some other zero-knowledge technology or stuff like this. There is this kind of cryptography which requires the common reference string with some secret to be able to create the proofs, to be able to verify them. It was discussed since like January. Actually, one of the first, maybe the very first public discussion about it was started by Chaser from Maker community. And the thing is that if we want to make this work, if we want to enable this Proto-Danksharding and later Danksharding and scale Ethereum to magnitudes, we need to create a ceremony which will compute this trusted setup number, this secret. We need to summon the spirit of the Dankshard. So what does it mean? Basically, there is so the setup needs this number which cannot be created by a single person. If I just pick some random number and I put it there and I know the number, I can falsify I can create I can break the security of the system, because I am able to do whatever I want. I can create fake proofs. So there cannot be a single person who knows the actual secret, which is in the Ethereum itself. This trusted setup ceremony is called trusted because we trust that nobody actually knows this number which is in the system. Tornado Cash, Zcash was created like this, and it was always ceremony with few tens of participants. And what does the ceremony actually means? It's multi-party computation. It's a way how all of us together can come up with this number in a way that we can rely on a single honest party. So we start with with some randomness, and each person in the ceremony adds his randomness to the mix. So you receive the powers of Tau, and you contribute your randomness, your entropy to the ceremony. You pass it to the next person, and the assumption is that if if everybody in the ceremony communicates and puts together the secret they put in the ceremony, they would know the setup, they would know the secret. However, if at least one person doesn't do that, doesn't keep his toxic waste, the randomness that he's putting in, the secret, if he doesn't keep it, doesn't tell, the system is secure. So we need at least one person who is honest there. And now the goal here is to create a ceremony so big that we can make sure that there is this person, the honest person, always available. Like the problem is also there might be bugs, there might be some issues, and even if you're trying to be honest, a bug might cause that you leak the secret number, let's say, or something like that. So we need as many people as possible to trust in the ceremony. And how to do it? All of you can contribute. It's ceremony.ethereum.org, which is this lovely website. Right now it's in the demo mode. It's not the actual ceremony. Talking about the roadmap, the parts of the ceremony are the cryptography implementation is going through multiple audits, the last one finishing these days, and in coming weeks this will be open. The actual ceremony will start open to public. Right now, if you go there, you find this. The UI here or the wording can change a bit, but it will look like this. So you come to the summoning guide, and when you click on begin, this is what you see. You enter your entropy. You enter the randomness, your own randomness to the system, to the multi-party computation, and there are three sources of entropy that are being collected. First of all, you move your mouse, you move the cursor, which the random movement that you do is collected in this green snake as entropy. And you put in secret, you put in some string, some words that you can type in, and also your browser, your computer generates a random number, and these are combined and added to the ceremony as your secret. If you want to contribute, you need to open the gates, open the way using either your Ethereum wallet or your GitHub account, and to have some Sybil resistance, some spam protection. And then you're waiting and waiting and waiting. If you see this, don't close the website. Wait, because somebody else is contributing right now. The computation takes a while, so there is some, 5 people in front of you. And when it comes to you, you have been called upon, and you help to summon the spirit of the Dankshard. So. Of course, you get some pop for it or something. However, this is the simplest way how to contribute. Just going to the website and going through this, I would say, pretty simple process. And if your setup is secure and if you're honest, this makes sure that you can be sure that at least you are the one who made Ethereum secure. If you are going to use this in the future, you can always say like, okay, even if everyone else cheated, I was the one who is right, so I'm not scared to use rollups. Yeah, you can see it says Sequencer is online. The Sequencer is a third party there, which is run by Ethereum Foundation. It's only creating the order of people who are contributing, verifying the contribution. It's not like trusted third party. It cannot reveal the secrets or anything. So this is how you do the contributions. Anybody can do it. Cats can do it. Really, like Hudson Jameson, maybe you know him. He, for Tornado Cash, I don't know which ceremony was it, he took his cat, put it on the keyboard to put the random string there, right? So really anybody can do it, but we need a lot of cats. We need lots and lots of people to do it, as I said, so please spread the word. If you are from various communities all around Europe here, come to your local community, organize a meetup, teach people how to do this, and avoid the FUD. I mean, if we say that Ethereum is now secured by a trusted setup, you know, the Bitcoiners will come, I trust Vitalik and everything, right? I mean, you don't want that. We want to make sure that anybody, even like people that are from different communities, like if some Bitcoiner or somebody who would inherently distrust the system, if he does this, he will make sure that it's secure and his community will trust that he did it properly, right? So please contribute, please motivate people to contribute. We would like to make it the biggest ceremony ever with thousands and thousands of people. The trade-off here is to have less powers, but more people contributing. So we are hoping in maybe 10,000 people or something like that. It will be running for months, basically until the implementation of the actual Proto-Danksharding is ready. So starting in like December, January, coming for a minimum of 2 months. If you want to learn more, go to this repository, Ethereum KZG Ceremony. It's non-technical. This is just a repository which lists all the possible resources. FAQ, you can learn about what is the KZG, how the ceremony will work, how to contribute, and so on and so on. So this is a great list of sources. And also, I would recommend the talk from DEF CON, where Carl, the actual researcher and who works on this, he's one of the masterminds behind the ceremony, explains how it works, maybe more deeply than I. And last thing I would like to say a few words about entropy in computers, because, well, there is this problem that, computers are calculators. They cannot create random numbers, right? They cannot, they just have, if they have chaos, it's always deterministic, because it's just some input and some output based of some function, based of some equation. So computers take randomness from the outside world. They need to get some electrical noise in a chip or from a microphone from something. If you maybe ever happened to you that you start your computer and you try to open dev random and it says, well, not enough bits of entropy, I'm not going to provide randomness yet because I'm still collecting it. Your system is still collecting randomness from various sources, because it's in the nature. A great example is Cloudflare securing their private keys, generating them with a wall of lava lamps, which are moving randomly. So the randomness is in the nature, and you can do various kinds of contribution to the ceremony. The one with the browser is the most simple one, but you can do anything. For example, you can use your cat, as I mentioned. So this is a paper which I'm working on, proof of cat, which is harvesting the entropy, the randomness from cats to secure the cryptographic systems to be able to contribute to the ceremony. There are various tools. There is like command line tool and so on. So if you come up with your own way, for example, a friend is taking noise from the relict from the microwave background of the universe, literally from the universe, right? And putting this as part of ceremony. So if you have some nice idea how to harvest the entropy from nature and add it to the Ethereum, it's really cool to say that, I don't know, cats are securing Ethereum, right? So you can also ask for a grant if you have some project in mind, and this is just my example. You can see the domain is proof-of.cat. It's actually kind of a local project. Any profit made of this will go to a cat shelter in Havel here. So that's just one of the examples, right? So yeah, if you have any questions, feel free to ask me. I will be around, and yeah. That's my Twitter, my email, if you would like to get in touch online. And I guess that's it. Thank you so much. I think I'm over time. Thank you, folks. I don't know if we have time for questions. Yeah.
Hi, first of all, thanks for being a bit psychedelic, because I participated in Manta Network Trusted Setup, and it was a bit hardcore, like 5,000 people, and then I saw that basically no one cared outside of either Polkadot ecosystem or whatever. Like, there's no awareness of what it is. But for Zcash, I heard the news that they basically, and I'm reading here, one of the latest updates, they removed a need for a trusted setup in case of hard forks and stuff like that. So if you will use them, there will be no complexity within the trusted setups. So the question is here, is there a battle between kind of the necessity or not of trusted setups? And what's your opinion why there are other bunch of folks who are promoting that, yeah, we don't need this, like that's a like useless thing?
Yeah, so like it's not, so it's certainly overhead. It's a trade-off. As I showed it here. You can, on the ETH research, you can find the discussion about this. And as I said, like the KZG was chosen because it has good properties except of the trusted setup. So now the discussion was, okay, do we want to go with something else or risk or go through the complexity of the trusted setup ceremony? And the researchers came up with reasoning that, okay, we can actually make pretty secure and verifiable trusted setup. And there are many implementations of trusted setup. Like the Zcash one was way back. It was done like, I don't know, less than 10 people maybe way back. So since then we learned a lot. There is the powers of tau, and based on this we do another iteration which I believe will be fully verifiable and pretty easy to do. Like it's so it's a trade-off, and with the current technology, with the community like this, I believe that we can actually overcome this challenge and do it securely. In a long-term perspective, KZG is not quantum resistant. There will have to be another, well, either another cool cryptography if somebody invents something, but it's not easy because the options there are really limited. Not just like in quantum resistance, but like especially now generally there is not so many options to go with. So this was chosen based on the trade-offs, and I think it's like the name of the talk by Carol there is How I Stopped Worried and I Love Trusted Setup. I recommend it, where he explains this. Because yeah, that's what happened. Like the researchers realized that it's actually pretty easily doable. So, but it's doable only if all of you folks participate, if you help us, right? So yeah, let's make it happen. And right now it's not that much discussed in the public because it's still relatively early. But in coming weeks, I hope that it will be everywhere and you will be ready. Yeah.
Sorry, David Chum recently presented Elixir and said that it's quantum resistant. Do you believe in that? In sense of
what is
the Elixir? Or David Chum, he presented and he said, finally we have a solution of quantum resistance and stuff. Have you checked that claim? And if you trust in that?
Well, I didn't check his claim specifically. Like naturally, I'm a bit skeptical. The NIST, the institute in the US, which is actually proposing the standards for quantum cryptography, has some really good candidates for quantum resistant cryptography, but I think we are not there yet in general. But there are many projects which are claiming to be quantum resistant now, also maybe with some trade-offs or like maybe not properly tested. But I'm honestly, I didn't look so closely into them that I can tell. But like in general, we can say that these what we are doing now is not quantum resistant. So there will be in the in some maybe foreseeable future, there will be some steps needed for that. And maybe also for changing to a new kind of cryptography in various systems, we might need more trusted setups. Actually, if the quantum resistant cryptography requires a trusted setup, we are ready to do it really effectively because, well, we are trying it now, yeah. Yeah, I'm way over time. Thank you so much, folks. Yeah, thanks.